Hi everyone, this is Mr. Zirkle, and this video discusses global wind patterns. In a previous video, we stated that Earth's surface is heated unevenly. This uneven heating is caused by changes in the amounts of incoming solar radiation that hit the surface. Because of this uneven heating, Earth's atmosphere circulates in predictable ways. Co- Energy or heat in the atmosphere is transferred through a process known as convection. Convection is the transfer of energy through a fluid due to density differences. As the sun heats Earth's surface, air at the surface begins to warm. This air expands and becomes less dense, causing the air to rise. This causes an area of low pressure to form at the surface. As the air rises, it cools, condenses, and forms clouds and precipitation. The cooler air, now being fairly dense, begins to sink, and as it sinks, it compresses and heats up. This causes an area of high pressure to form at the surface. Now I want you to pause the video here and jot down this video in your notes. All right, this type of atmospheric circulation that you see here is called a convection current, and it happens on both a local scale and a global scale. On a global scale, intense solar heating at the equator causes air to rise. As the air cools, it condenses, causing bands of clouds to form near the equator called the intertropical convergence zone. And you can see that right here, this band of clouds that goes across the center of the globe. As a side note, this zone of clouds is where most tropical storms and hurricanes first form. The rising air at the equator eventually sinks at 30 degrees latitude, creating a large atmospheric cell called the Hadley cell. The Hadley cell is one of three major atmospheric cells that moves air globally. The Ferrel cell, which occurs in the mid-latitudes, occurs when air sinks at 30 degrees north latitude and rises again near 60 degrees north latitude. The polar cell occurs when air rises at 60 degrees latitude and sinks at 90 degrees latitude. These three cells occur in both the northern and the southern hemisphere. Now, let's take a moment and fill this in or draw the atmospheric circulation in your notes. Remember, air at the equator begins to rise. This causes low pressure at the surface and clouds and precipitation. That air rises and begins to fall again at 30 degrees north latitude. This is the Hadley cell. The sinking air at 30 degrees compresses and warms, forming high pressure at the surface. Some of the sinking air moves to the north and begins to warm, causing areas of low pressure to form at the surface. It rises again at 60 degrees north latitude and it forms the Ferrel cell. The rising air moves northward, cools, and begins to sink again near the poles. This is the polar cell. These cells are mirrored in the southern hemisphere. It's important to note that many of the world's great deserts occur near 30 degrees north or 30 degrees south latitude. You can see this here in the diagram. The Sahara Desert is located near 30 degrees north latitude, as is the deserts of the American Southwest, and also over here in much of the Middle East and Southwestern Asia. This is tied directly to the sinking air of the Hadley cell, which causes the air to sink, compress, and dry out. The uneven heating of Earth's surface is also responsible for wind. We know that the uneven heating causes areas of high and low pressure to form at the surface. Air flows from those areas of higher pressure into areas of lower pressure. Earth's rotation causes the wind to change direction as it moves over a long distance. This curving of the wind due to rotation is called the Coriolis effect. In the northern hemisphere, the wind is curved to the right, while in the southern hemisphere, it's curved to the left. Now, let's take a look at the major wind belts and how the Coriolis effect causes the air to curve. Some of the sinking air at 30 degrees north latitude moves southward, and as it does, it begins to curve to the right, as shown. These are called the trade winds, and they're what helped early sailors cross the Atlantic from Europe to the Americas. Now, I want to point out here that if you look at the green arrows, they do appear to be pointing left, even though I said wind curves to the right in the northern hemisphere. Well, what you need to do is put yourself in the place of the wind and look southward toward the equator. And then as you would begin to move toward the south, you would actually begin to turn to the right, which actually looks left on this picture. And it's actually kind of confusing now that I think about it, but hopefully you understand what I'm trying to say here. Um, at 30 degrees north latitude, some of the air also moves northward. As it does, it curves to the right. These winds are called the westerlies and are what move our weather from west to east. Finally, up north, we have the polar easterlies. These wind belts are mirrored in the southern hemisphere. These large circulation cells and wind belts we just discussed are responsible for much of the climate of a particular location. They are the reason certain biomes exist where they do, and they also play a large role in the weather that occurs in our daily lives. All right, well, that's the end of this video. If you have any questions or concerns, please message us. Otherwise, we'll see you soon.